Hey folks, I'm from the land of ones and zeros. Let me know where you're from. So recently I posted about doing one project around RTL coding, verification, architecture design. These three are the major domains I want to try this project on. So it has obviously some prerequisites. I need to know basics of computer architecture. Since I'm doing a accelerator project, I'll be designing one GPU, which will be focused for AI workloads. So I also need to study parallel processing architecture, parallel computing architecture. So first I tried with I started studying with this sequential computer architecture. I was reading this PDF from GFG. It's very good. I recommend this. I stumbled upon this one architecture, which is simplified instructional computer. It has no pipelining, nothing great in detail, but it's very important for educational as well as for practice purpose. So I had an idea of coding for this architecture. It basically has five registers. It has a memory of 32 kilobytes, in which it should be byte addressable. In the later part of the video, I'll show you the code for this. I did that. I took help from ChatGPT, but yeah, I understood the architecture. I understood the specs. Then I started coding. So it has five registers. It has some data format. It supports integer negative numbers using two's complement. That's okay. It does not support even floating point representation. You can see it is that naive, but it's good for learning. It has instruction format. All instructions should be in 24-bit format, out of which here it's 8 bit of opcode, but in mine it's 6 bit of opcode. One is for the addressing mode. I mean, if it's direct addressing mode or in the index addressing mode, and the rest of bits are for address. In my architecture, I'll be testing this architecture upon some these instructions, which are load, store, compare, some arithmetic operations like add, sub, multive. These will be there. Also, this will support input and output functionality. It's not that complex, but then yeah, I tried coding for this. Uh, yeah, this done. So let me walk you through with the code base. See, this is a standard working directory which will be used in most of the industry grade projects basically. So it has a docs folder which I didn't do anything about this right now. Let me walk you through with this RTL. It has 5 files. First is the CPU. It defines the working of this whole architecture. It has all these ports. A few parameters are also there, which is address width and data bins. I have purposefully given this as parameter, given these as parameters, as it's the code will be configurable. You know, it's you can reuse it for multiple address and data bits. Uh, you have an instruction decoder module, which we'll see after this. You have one ALU module as well, which will do basic add, sub, and then it will also compare if the value if the value in if the data in register A is equals to in the is equals to the value in register B or less than or greater than three operations. Uh, and then it's basic FSM. It has three states: fetch, decode, and execute. Based on this logic, it has. Uh, so I told you I tested this upon a few instructions. It load, store, add, sub, compare, and jump. These are the basic instructions I'll be testing this architecture on. Okay, this is done. Now I'll walk you through with this ALU. Nothing great, just addition, subtraction, and then you have this comparison. If it's equals to, then 100 flag will be set, and apparently for A, for less than and greater than as well. This model is for instruction decoder. Uh, Throughout the architecture, I have taken data width as 24 bits. Opcode is, as I told you previously, it's 6 bits. Address width it's is 15. Okay, it just takes the instruction and assigns the opcode address and index flag based on this. It basically decodes. No, this is done. This is for the input output interfacing. It has nothing great. So I didn't want to increase the complexity of the project, so I added this thing that device is always ready to take interrupts. Um, this for the memory, this is the memory size is 32 kilobytes. Again, the data size is 24. Uh, Address width is again 15 bits. Um, yeah. So since it's the word size is 24 bits, so 3 bytes. No. Based on this principle, this memory is designed. And then there is a top module which wraps everything inside, all these things. And it just takes the instruction from the memory, the read data, which is in the memory, and does the whole computation. I have tried adding test benches for that, but then I had this issue. Some Git issue was happening. Then I had to reset my branch. So spawn. I'll not code for test bench for this architecture. I learned what was needed to be learned from this architecture. That's enough for me. Aha, okay. But then I have to try this UVM on this project before I do UVM like this verification using UVM methodology on the final project. Before that, I'll try this UVM with this project. I'll see how it's done. I don't know anything about UVM right now. I'll explore. Yeah, I have to revise some system Verilog concepts. Most of them I know well, but then some things are there like communication interfaces. I know constraints. That's okay. I don't know about this constructs. Yeah, good point. I have to see how to achieve full or like maximum functional and code coverage as well. I'm not sure about that, how it's done. Also, I since I'm using QuestaSim, I'll have to see how do you get the coverage in the terminal only. I don't want to open the GUI for QuestaSim. I just want the coverage percentage, functional coverage as well as code coverage in the terminal only. So that's it. Now I'll take some more time. So you're searching in this chat GPT. I told you about the NVIDIA architecture. No? So this is NVIDIA Turing architecture white paper. I'll take few inspiration from this architecture, not few, a lot of inspiration from this architecture, and will design my own architecture. But then I asked ChatGPT, so it said that, okay, I asked this, do you know some alternative Turing level architecture which are open source? Since this NVIDIA one, it's not fully open source, they just gave the white paper. If I'll do some research, I can find more, I can research and find more about this, but then I'll not get the actual specs I need for the RTL coding, right? So I asked this and It gave me some options like NVDLA, a rocket chip, but I don't know. I didn't research about them as of now. I'll look into them, and I don't know how big are they, how much is their complexity. I'll have to see. So you can see it says not a GPU, but Turing like single instruction, multiple data core. Yeah, I'll have to explore all these. So this is the update I wanna give you guys. Also, I'm doing some research around DRAM. Basically, we have to adjust the refresh rate of DRAM in extraterrestrial environments. So if in future we'll be going to Mars, Moon, and all these extraterrestrial places, so-called places. So we will be needing SRAM for all these. So I have to do this because it's needed. So that's it from this one. I don't have further updates for you guys. I'll be back with another one. So yeah, bye. Take care.
Wanna be the greatest. Everybody on the fake shit. I look around and feel like everybody is the fakest. I make this every day and I'm impatient, hoping one day I blow up from the basement. Statement, the top is so vacant. I don't hear shit that I think is amazing. Waiting for my day when I'm playing sold out shows for 1,000 faces.